All right, and welcome back. And part two here, we're going to go ahead and start and get into some real quick discussion about the discovery, setting up routers and what routers are in terms of IP control and devices. And then I have just a real quick example here on, that will do that and be able to run that discovery there. And then we'll also go over some of the other components under the IPAM, some of the options that you might be interested in, and then start to get into the next videos for DNS, set up domains, and others before we get into the full network capacity here. All right, so one thing I said I was going to do earlier is set up the other private addresses, which I need to do with my 192 address space. And I'm going to do this down here in Southeast because I allow this. If you recall, in the container maintenance, we allowed for the root block that we could say could be defined down into the state level, to the region level, but not at the individual site level. So I think here, and probably to allow us to look at some of the overlap, I'm going to go ahead and allow this here and create my own private block. And I'm going to create this as a private v4 16, so I can use the whole thing. I'm not going to create a domain for that, but I will check the overlap. And that'll then allow me to create in, say, other sites that are states, or in other parents other than Southeast, I can create another duplicate. And from there, I just want to leave that there. So routers, let's go to management and network elements. And what a network element is to us is basically a layer 3 device. The layer 3 device can be a router or it can be a layer 3 switch. Now I have one here I call RV320. It's a little Cisco router I use in my lab. And from an element type, there's really not much of an importance really other than switches. When we think about routers, this is actually a layer 3 switch. I'm going to define switch here. But when we think about this, we do discovery of MIB2 and we query the if table of MIB2 and we pull out the interface and then we query the links and pull the indexes. And it's typical across all devices, 98% I'd say, support this capability. New switches and routers from Cisco like the Nexus iOS do not support MIB2, and therefore we have a different concept of discovery that uses SSH. So if you're interested in Nexus, I'll show you that here in a second once we get done with this, and then we'll go to the next one. Now from a model, in terms of the router, we don't really care what this is. We have some predefined pieces here, but we're not using it for anything. It's really for your benefit and tracking. And if you need to manage models and vendors, that will be under Tools, Vendor Models, where you can define each individual vendor and for each individual device type, what those models are in your environment. Now, from a discovery, I'm going to use v2 because that's how mine's defined, and I just use a real simple string. But we can give it a timeout as well in milliseconds, so 2000 is 2 seconds. And we can tell it to retry twice. Since this is SNMP, I'll use SNMP, but the Nexus routers would have SSH and then your SSH credentials. And then by default, any device, appliance, or just the executive that's been created in IPControl has an agent, and that agent can run discovery. So we want to, effectively here, we don't want our DNS to do this, but we want our executive to run our discovery. However, we could have multiple agents distributed geographically running different discovery times that are distributed that just send back their updates. And we can select by region which discovery agent would be used. I'm going to use executive agent to keep this simple. Now, for different routers, you can have it set up as a task to do a global synchronization of all of its router checks and subnets, or you can manually or set at recurring events each individual router. I'm going to do this as a both option to give you a choice. And you can also define a template for your router so that if someone were adding a new router, you might have a predetermined interface name set that goes with that you would define. So I don't, I'm gonna go ahead and just hit submit. This is now just a device element, but it hasn't really been associated or attached. So what I want to do now is go to Management, Container Maintenance. And because this is in my Atlanta office, I want to add a container. And under type, select device. When I do search, I'll select RV320, and I can again select any kind of user-defined fields I want here, and any kind of types, policies, or so forth. Now we're going to allow everything because we don't know what's here, and we're going to hit submit. When I go and do a refresh now, I have this Cisco glyph that appears that shows us the router. And if I were to try and say add another container and I do a device and search, you'll notice that there's a link showing that it's attached. So if you had new routers, it'd be quick to see which ones are in use and not in use. And lastly, what I want to do, because this I think is already set up, is I want to go now to Management Discovery, and I'm going to do a router discover subnets. So discover router subnets. And I want to do just for this one element. You could have, and we do this often, set up a site that has maybe multiple routers or all of the routers that you want to be set up in Discovery. They can all exist under a single container, and you can have then network engineer views versus your IP admin views. And that then would allow them to discover full containers in all of the routers in a task. So there's ways that you can organize this to think about. Now, I'm not going to tell it to run the import when it's done, but once you've set this up and have discovered and things are clean, I then recommend you set it up. You can then tell it to import new interfaces automatically if you're doing this outside of IPControl. And we're going to run this immediately so we can do an immediate discover. Let's see, our task 9 is discovered. I'm just going to jump over to our task. It's usually very quick. And you'll notice that the first time you do a discover, you'll have almost always a complete with errors. Unless you've defined an interface template and all of the interfaces are defined and you've manually attached the subnets, it's always different than what's in IPControl. When you click on that list, you're going to be given a list of what's allocated, what's not allocated. Now, I did actually tell it to attach that information on the import, and you'll notice that it did not import some v6 addresses. So you're going to see informational attributes about what happened, what was successful, what was not successful. You can resubmit this task, and we can also look at the differences. So in the difference table of this router, it shows us that it's configured, it's on the router, and is but not planned, meaning it's not in IPControl. And there's our subnet. I did not include the 172, right? This is a different subnet. And then there's two others that I didn't define as well, but they show up as configured on the router, but not necessarily in our subnets. So what should have happened is where it could have attached a subnet or created a new one, it did. So it had the network space for 192.168.1, and it could create 1, 2, and 0. So the 2 or 3, or the 3 that it discovered were automatically imported and attached to this interface. And when we look at it from a container view, you'll see now the interface name that it founded that information on, and the subnet itself. And you can click through it now, and we would see the individual IPs. Now, as I mentioned, the interfaces, when you deal with routers, when we do a discover, we define them specifically as interface. We create that automatically, and we assume whatever name you built on the network element, whether fully qualified or individual. That type then is only allowed for that router, but it does not then go out and set up a link of each individual device. It doesn't do that here as you would the server. You could, however, under network elements, look at the device, see its individual interfaces, and here you could associate the VRF manually, or you can set up whether it's disabled or in a different state. Okay, so that's a real quick way of discovering the network information from that capacity. And I don't want to go out and do the discovery yet of the host names until we go through the DNS, and then we'll come back to that part there as well. So we just demonstrated, setting up your networks, which you need to make sure that anytime you do discover and attach and do automatic imports, at a minimum, we do need to have a root network, and that root network needs to have obviously free space. And under that free space, you should have it organized, I guess, in a way that's logical to your environment. And your router should be defined in areas that have access to that information, right? So that IP address space. And what I mean by that is if we look back at each individual tier, say in Georgia, this IP address space, the 20 space, is not available anywhere else. The 192.168 is not available anywhere else above Georgia. It's only available to its child containers at this level, and only available to the child containers based on its block type as we defined in the container policy. And then when we do routers, they attach effectively any of those policies supported at that level in subnet space. And if it doesn't exist, it'll create a new subnet. If it does exist, it'll attach it. So as you'll notice, we have on the router here these subnets, but the subnets don't exist here. If I wanted them to be viewed here, I could do what's called an attach. And I would go take a look at, say, the 24, look at the data, and it's going to show me, which ones are allocated and which ones are free. And I could then go in and effectively attach that information. Right now, so I don't think I've set up private to allow me to do anything with those. I only had data and so on. So these haven't been, set up the way I would want these to be set up at this level. So that's just a real quick discover. Now, also under here, you're going to have, after time, you're going to have discovers, and you're going to collect statistical information. How many times it was pinged, or how many times the subnet was discovered on the router and compared. So you're going to have the ability to go through a reclaim. And by default, it starts with manual. And here you can do IPs or subnets and effectively give it a scope, such as a site or organization or everything. And then tell it, number of days since the discover, number of attempts, other filters, and it'll effectively give you a list of things that would fall under that category that you can then say, well, it's static, I want to delete it, it's no longer in use. Or in dynamic stints in DHCP, that would all be taken care of for already. Right? So I'm going to, I think, go through one more setup here, and let's go through the domains and set up at least some basic things that we can get established at our subnet level, and then also before we do the discover of the devices. So in your DNS domains, we can go ahead and assign a few things, and as you'll see, we've already created the INAT or ARPA from the dot. So we start with the root, and when I went and defined automatically in the network the 10 INAT or ARPA, it automatically created the dot INAT or ARPA, parent domain, and then the child. If I click on this INAT or ARPA, you'll see that it's not managed, so we don't manage, but it is delegated for reverse domains, which is required as we move down the INAT or ARPA space, so we need to have that in the domain. The 10 space, however, is managed and delegated, which means that I can now delegate this to a DNS server, i.e. our server that we're working with, and then any changes made to this reverse zone would be deployed to the server, either dynamically if we allow, or through some configuration checks. I want to add my forwards though, so we have a way of doing this in our setup. So let's just do let's do IPC. IPcontrol.int, just as an example. I'm going to have this as a forward domain managed delegated. I'm going to give this to a server who's going to manage it. And at the domain level, if I wanted to have other information like assets and other fields set, I can associate those here. So just keep that in mind. The serial number down through your contact, these are all parts of the SOA or start of authority required for bind. If you need to set serial numbers, you can adjust them here and change that. The derivative means this is a standard zone type. However, I could say that we're also going to create a template, meaning that when I move forward, I might have what they call vanity domains. And in the vanity domain, you might have multiple domains for products that tie back to a single host. And anytime you query one of those vanity domains, it resolves it to that domain. So we can do this simply through what they call CNAMing of the domain or alias domains. We could establish this as a template to start with, and then future domains would then be associated to this template. So it's a way of doing, cheating way of simplifying the records, since you may have to use them in different domains, different resolution. A little bit more advanced, maybe we'll get into that another subject. But also catalog zones. And catalog zones are new to IPcontrol and bind 9.11 to effectively in our master, we can set up that this is a catalog, and this catalog is deployed to a master, and then your secondary servers subscribe to the catalog, and anything added automatically gets added to the secondary. So instead of having to redeploy new changes in the config, it just knows that a new domain requires a transfer, and it establishes that trust and transfer. So we're going to use this as a standard to go through our single principle here. This then is a very, very basic structure. We've got a forward reverse domain, and I'm actually going to go ahead and do one more. I like to do this. I'm not going to do it at the network level and tell it that it's reverse, and go ahead and hit submit. Now let's go ahead and just real quickly delegate this to our server so we have something here to look at. And the way we do this, and I'm going to do this in two different ways in several different videos. The typical way is to add DNS zone, where you would go in and define a type in terms of delegation, and we need to have established at least a master, and that's kind of what we're doing here with this appliance. Once with the master then, and my system will reload here, we'll then tell it the domains that we've created, and we'll go ahead and just start with our internal IPControl domain. We're going to tell it what the file name is when it gets deployed to the master server, and I'm going to go ahead and establish automatic glue records. However, if you were trying to establish a hidden master in this case, you would not select that. You would then also set an alternate M name, and this alternate M name would typically point to an alias of another server or to your secondary DNS who you want to be published as its authority record in the SOA. So it's effectively changing the authoritative M name address in the SOA. So I'm going to set it to auto because that's one of the capabilities of the server. And I want to include the master in the DNS list. So even if I create secondaries, I can exclude the record automatically. The allow DNS listener, and if this were a dynamic zone, I'm going to make it dynamic. So we're going to use this and set it up. Allows us to effectively listen to notifies from external DNS servers when they dynamically change, and we zone transfer those changes. We incrementally update the database, set up the audit trail, and we can also interact with those records and say deploy them to other servers. So very, very capable. And in order to support that, you would then need to have your address list. And I'm going to do just local nets in our lab example here, but we'll get into this. And to allow it to set up dynamic updates. And I'm going to use the allow update policy, but I could allow it to do a more complex update policy, which again, we'll get into another complex discussions there. So in this zone, if I had other types of settings I wanted to define that were not already set in the policy at the server level, I could set that information here. And I do want to go ahead and set some, such as allow query. On the allow transfer, I'm going to do local nets, but we would typically do just your other secondaries, which I would have others. Now, there is also an also notify if it's dynamic. And if you're also notifying, you would set this up to be your executive. And we do this on 5053 or 53 if you're redirecting the data. 5053 is the default. This then allows the listener to capture on that data, and it starts on that port by default. There's a many other settings here, but some of the typical ones, and I'll show you how you can set up templates for this, are all available in this list, and effectively everything for this version of Bind that you might want enabled. Now, just some typical things that you might have set here. Go ahead and set up your notify yes. We can either set up a source, but we're going to keep all those same. We'll do zone stats. And the serial number, we're going to do increment for the dynamic updates to keep that in check with different dates. And we'll hit submit. And when that's done, it'll return, and those values will be set here. And then also know when you go back into the zone options again, it will only show you the one selected. And if you want to show other options, you can click on here. And if you have any kind of zone extensions, again, text, you can put that data back into the text fields as well. So let's go ahead and do our reverse zone and do master again. And I won't talk through this one. And finally, our 192.168, which is our local net that we're going to use here. Okay. So now we've associated basically these three zones to that server, and that server now in delegation has master authority for these records. And if we were to go look at any of the zones without even having to go into the subnets or anything else and look at any of the zone records, we would have the ability to do that. So I then want to go ahead and because if I can then create resource records and we can deploy them out to the server. Right. So just to get these records in the zone configuration out to the server, I'm going to tell it to go ahead and do another configuration deploy. I want to tell it to do all files this time. And we're going to tell it to go ahead and do a submit. Now this is dynamic. It does give you a warning. I don't have any dynamic entries to be replaced, but note that when it does do this, it replaces the journal files. So there's a procedure we go through for that process. And again, in this task, as we look at this, it generates the files locally first, and then notifies the agent, which then connects back to the executive and downloads the individual files. And I don't suspect anything's wrong in the config, so we should have everything working okay at that point. And if I were to do some type of NS lookup, let's see, 57, just server. Let's do control. I can't type this morning. All right. So then we have the primary name server, and you can see our SOA, on the zone. So we know it's out there. No records still, but there will be eventually. All right. Now, the one other thing we want to do, and typically a standard practice, anytime you build a DNS server and its IP, in IPControl, we also want to define that IP address. So I want in this subnet, since I'm managing it with this, I'm going to go ahead and do IP address. I'm going to go ahead and just select it. I don't have to navigate to it. And then I'm going to tell it that this is a server, static, and that this is VM NS1. Actually, was it DNS1? And its domain, I want to set to IPControl ends. And the checkbox for resource records. And when I look at resource records, then it shows what is auto-created. This name then requires that the host name is DNS compliant, no special characters outside the underscore or dash. Very, very restrictive about how things are done there. Okay. You can assign other resource records, assuming your administrator has that access. We do. And these other types, then like CNAMEs or text records, SRV records can be generated as well. Right? So we're going to go ahead and submit that, and at least through IPControl, and for the glue record, that automatic glue record, NS record, that's what that information looks like. Now, we can go out here and do two things, but I want to go ahead and see one first, if we can generate our dynamic update. And let's do change resource records only via dynamic update. I'm going to skip any CNAMEs, and let's just hit submit and see if we actually pick up those records and updates. Because it's a name server record, it may or may not allow us to, but we'll see if that does. And it does say that it did. And if we look down into the task, into the further details, you'll notice your dynamic records here were updated. All right, so we got some control and some updates, some capabilities, and we have now our primary domain. So one thing I wanted to do, because I'm going to go back to my lab where I'm actually working in these, instead of policy that says for my forward domain, I want this to be IPControl int. My reverse domain, I want this always to go into the root. And for the DNS servers, I want to associate it to the server. And the reason I want to do that is because I can later use these values in the DHCP configuration to associate these options automatically and to save you in the templating and time in the administration. Right? So that was very basic there. And then let's go through one other discover, which is the ARP Discover. And that will use from the network element SNMP, the ARP tables, and allow us to query. We don't recommend you do this before you do DHCP scopes, however. So if you're going to get into DHCP scopes, I would probably save a snapshot of your database or think about doing this. However, I'm going to go ahead and just show it. I'm not going to do the net addition, so I just want to show what it looks like. And we'll tell it to update the other settings here and then perform reverse DNS lookups against DNS if you want to have these records. But don't do the net host additions yet because we don't want to import and have to delete them and come back. And in that task, that goes usually very quick as well. And you'll see here what it found, how many hosts and discovered. And because we didn't import them, we should be able to kind of go to that subnet. And in the plan versus actual report tab, you can now see some of the host names. It queried my local DNS, which I have for each of these devices, and pulled the hardware, the host name. You'll notice I don't have this domain, so before I did any type of import, I would want to automatically, go in and create that domain as well, which I'm probably going to do as in addition. So it found these devices, and since I do want to use that domain at some point, I'm going to associate this to another server to show other features. I'm going to create my lab domain just very quickly. And I want to go back to this list. And I want to go ahead and just tell it to import them. And although I wouldn't do this if I'm going to do dynamic, I'm not in this case, but select for the records that you want to import or make changes to and click Save. And where it can, it'll import those records, associate them to the IP address, and then assign them to the list. And whichever ones it can't, like these, it couldn't determine a MAC or whatever the devices were, or a host name. If they don't have fully qualified host names, they obviously can't be listed. So now let's kind of get a different view of the records here and show only the used IP addresses. And now you'll see that we have whatever records were imported, their proper domain names. You'll notice also some of these that were discovered that I didn't know a type were unspecified, because there's really nothing out there that's going to tell you a device type that matches to whatever you've defined in IPControl. These are typically, DHCP addresses out there in the network, and we bring them in as unspecified because, again, we don't know, or they're not in DNS. So just other visual indicators. And as I mentioned, you'll see that these are all listed as static, which may or may not be how you have your IP addresses listed. So the one thing I'm going to do is I'm going to go ahead and just delete all these because I really don't want those listed that way. Although I just deleted my server, but we'll define that again. And what I do want to have in this particular case is I could go in and create a DHCP pool in the subnet. So actually we'll select it. Let's do manual 200. And let's tell this we're going to start from 25. We'll give it dynamic DHCP. We'll tell it to inherit the DHCP server and failover from the subnet profile. That way we don't have to come back and manage this at a later time in a subnet. And if you're getting into client classes, allowing and denying MAC address checks, black address, black pooling, you can do all of that here through the other assignments under the DHCP client class menus. So we're going to go ahead and create submit. Now notice that I couldn't do that if I had other addresses there. That's why I had to delete them first, because it goes in and creates a contiguous range. And this now represents each of the individual addresses. So one thing is if I go back to this list and I take a look at this list and try to import these again and hit save again, this time when it goes import, it says that these addresses are already in a pool, right? So the DHCP server is expecting to pick those up. The discovery is really used for static addressing and things outside those servers. So just keep that in mind when you're using discovery. You'll see a lot of information. Don't necessarily import it automatically yet until you kind of go through some of those settings there. Okay, so that's a long video, and I'm going to leave that as part of the second video and some of the discovery and setup. And again, kind of going back to your screens, that gives you, your router configuration here. And in future videos, we'll go through some of the importing and how to bulk load routers so that you can set this up, globally versus just the one-offs we're doing here. All right, thank you, and see you in the next video.